If you're studying for the INBDE, I highly recommend INBDE Bootcamp, an all-in-one study resource that will help you pass your exam. Use coupon code MENTALDENTAL for 10% off. Hey everyone, Dr. Ryan here, and welcome back to our Biostatistics series. In this video, we'll be talking about variables. So what is a variable? Well, it's an observable or measurable characteristic that can assume a range of values. In other words, a variable is anything that can vary or change within a study. Variables are elements that researchers measure, manipulate, or control in order to understand their effects or relationships in a particular study. For example, in a study investigating the impact of brushing frequency on oral health, the frequency of toothbrushing, whether it's 1 time a day, 2 times a day, or 3 times a day, would be a variable that could be manipulated to examine its effects on oral health outcomes like plaque accumulation or incidence of dental caries, which, by the way, are themselves variables as well. By contrast, something that can only have one value and is not changed is called a constant. If you're familiar with algebra, you've probably seen the slope-intercept form of the equation of a straight line, which is y equals mx plus b, where m is the slope of the line and b is the y-intercept, the y-coordinate at which the line passes through as x equals 0. Now the yellow-colored xy coordinate that's located on the line consists of 2 variables that can change depending on where you are on the line. Of course, this is one possibility, but this point could be anywhere along this infinite line. So in a research context, if this line is the truth, then the x and the y values are what we're trying to figure out when we investigate a research question. I do want to clarify and distinguish between a variable and a value. Stated simply, variables have different values. A variable is a characteristic that can change within a study, while a value is a specific measurement or description that a variable can take. Here's a table filled with examples to help solidify this concept. And you'll notice each variable has many possible values. So eye color is one variable. This could be brown, blue, green, hazel, gray, or amber. Glove size could be small, medium, or large. Of course, there's other options not included here. Pocket depth, periodontal pocket depth that is, could be 0 millimeters, 1 millimeter, 2 millimeters, 3 millimeters, and so on. Caries risk status could be low, medium, or high, and the type of toothbrush being used in a study is another variable, and the values are either manual or electric. In the context of clinical research, there are so many variables we could talk about involved with human subjects that vary from person to person, such as age, sex, height, weight, body mass index, blood group, body temperature, blood glucose level, blood pressure, heart rate, number of teeth, and severity of any sort of disease, whether it's mild, moderate, or severe. Next, we have to talk about operationalization. Try saying that 3 times fast, by the way. Operationalization of variables refers to the process of defining variables in a way that allows for their accurate measurement. So let's introduce some definitions and categories of variables. Here on the left, we have the independent variable, also known as a predictor or explanatory variable. This refers to the conditions or factors of an experiment that are manipulated or controlled by the investigator. In this image, if we wanted to know how watering a plant impacts its growth potential, the frequency at which we water the plants would be our independent variable. Maybe we water some plants multiple times per day, we water some plants once a day, and we choose some plants not to water at all. In the dental context, this could be, say, application of fluoride varnish or the use of an antibiotic. Over on the right, we have our dependent variable, also known as an outcome or response variable. This refers to the measure or outcome thought to change as a result of the presence, absence, or manipulation of the independent variable. So going back to our plant experiment, our dependent variable could be the height of the plant. For clinical research, this could be treatment outcome, disease outcome, mortality, cost, and many other possibilities. In summary, the independent variable is manipulated by the researcher, and the dependent variable is measured by the researcher. But we can also have something else in the picture, a confounding variable. So a confounding variable or confounder can get in the way of our results. In a cause and effect study, where we're trying to determine how an independent variable affects a dependent variable, a confounder is an unmeasured variable that distorts the relationship between these two. For example, sunlight could cause some plants to grow more than others and distort the clarity of our findings. A confounding variable can strengthen, weaken, or even eliminate the relationship between the independent and dependent variables. So we have to carefully watch out for those whenever possible. Generally speaking, we can break these variables down into 4 categories depending on the set of data that they provide for us. These are referred to as the 4 scales or levels of measurement. Qualitative or categorical variables are on the left, and these are your descriptions, and quantitative or continuous variables are on the right, and these are your numbers. So let's start first with the nominal data. So I want you to remember for this one, names or labels. The word nominal literally means in name only. So nominal variables are things like marital status, eye color, or hair color. There's no measure of distance between the possible values. For marital status, are you married? It's either yes or no. Let's say, are you pregnant? Either yes or no. When you have a binary choice, either yes or no, right or left, that is called a binary variable. But nominal variables can also have multiple options like eye color and hair color. Blood type is another example of a nominal variable with multiple possible values, either A, B, AB, or O. Next up is ordinal. And so I want you for this one to think of order or ranking. There is a ranking to the values. Going back to nominal for a second, you don't rank male and female, but for ordinal, you do rank stages of cancer as higher or lower. For example, stage 4 cancer is more severe than stage 1. Hypertension stage 2 is more severe than hypertension stage 1. Or have you ever heard this before? On a scale of 0 to 10, how much pain are you experiencing right now? That's a pain scale. And there is a ranking or an order to how much pain you are feeling in that moment. A Likert scale used on a questionnaire may provide 5 options. You either like somewhat, you're neutral, dislike somewhat, or dislike something. Other examples of ordinal variables include socioeconomic status, either low, middle, or high income, and education level, either high school, bachelor's degree, DDS, MS, or PhD. Next, we move over to the quantitative variables. So for interval, I want you to think of integers and the range of numbers between those integers. And this is important because we can have numbers in the ordinal category, as we just saw. For instance, the pain scale was from 0 to 10. And those numbers have a meaningful order or ranking to them. But the intervals between those ranks are not necessarily equal or quantifiable. For example, for cancer, there's no stage 3.5, or for hypertension, there's no stage 1.5. By contrast, take an interval variable like temperature measured in Celsius. There are equal intervals between all values. For instance, the difference between a temperature of 30 and 31 degrees Celsius is the same as the difference between 31 and 32 degrees Celsius. It's 1 degree different. Sometimes interval variables have a range of infinite values, like temperature. Not only is there 36 and 37 degrees Fahrenheit, but there are infinite measurable values between those two. Other times, interval variables are simply whole numbers, like an IQ score, or a credit score, or any test score for that matter. pH is another common example of an interval variable. And lastly, we have the ratio variables. For this one, I want you to think of the word 0. And that's because ratio variables have a range of values with a clear definition of 0. So it's the same as the interval variable. It's very close, except it has an absolute 0, which in effect allows you to compare these values as true ratios, hence the name. So let's take temperature measured in Kelvin, for example. Now all of a sudden, we have a ratio variable because we have an absolute 0. You may ask, well, we have 0 degrees Celsius, or we have 0 degrees Fahrenheit, Dr. Ryan, so why aren't those considered ratio variables? Well, because you can also have negative numbers below that 0 value. With Kelvin, you cannot have a temperature below absolute 0. It's impossible. Other examples of ratio variables include blood pressure in millimeters of mercury, age, height, weight, enzyme activity, dose amount, reaction rate, flow rate, concentration, pulse. There's a ton of possibilities. And for all of those I just listed, you cannot measure below 0. You can't be younger than 0 years old. You can't be shorter than 0 inches tall, or less than 0 pounds, or have a blood pressure less than 0 millimeters of mercury. It's just not possible. So putting this all together, in summary, a nominal variable categorizes and labels values. An ordinal variable also ranks categories in some sort of order. An interval variable has known equal intervals, and a ratio variable has a true or meaningful 0. Each one, as you can see, builds upon the last. So we spent a lot of time talking about those different categories of variables, and you may be wondering at this point, why is that important? Why does this all matter? And it's because depending on the data that you collect, that determines what statistics you can calculate with that data. Generally, the more evolved your data is, from left to right here, the more statistics you have opened to you. And this table summarizes the capabilities of the various levels of measurement that we just reviewed in the last slide. If you're using nominal variables in your study, you will be able to calculate and utilize frequency distributions, but that's about it. If you use ordinal data, then you can also calculate the median, mode, and range. If you're using interval variables, now all of a sudden you can also do some addition, subtraction, calculate the mean, the standard deviation, and the variance of that data. And lastly, if you're utilizing ratio variables, then you can do all of these things, plus you can use multiplication and division, and you can calculate ratios and the coefficient of variation. We'll be talking about these statistics in detail later in the series. So now I want you to get some practice. So for each of these variables, I want you to write down which of the 4 levels of measurement correspond to each one. So go ahead and pause the video, work through this exercise, and then we'll go over it together. All right, so the answers are appearing on the screen in 3, 2, and 1. So let's review this exercise. The first one, number of teeth in a patient's dentition, is a ratio variable because it represents a count of teeth that can be measured, and it has a true 0 point. Having 0 teeth means no teeth at all, and you can't have less than 0 teeth. Class in dental school, so you're either a D1, D2, D3, or D4. Of course, some dental schools have a 5th year, other programs have less than this, but it doesn't change the outcome. So all of these classes are given a name or label, but they're also ranked in a specific order. 1st year, then 2nd year, then 3rd year, then 4th year. But the differences between the classes are not quantifiable in a meaningful way. The difference in progression from D1 to D2 is not necessarily the same as from D2 to D3 in terms of experience or difficulty. So we can't say this is an interval variable, but it certainly is an ordinal variable. The presence or absence of oral cancer is a nominal variable because it represents categories with no intrinsic order. They're simple labels. It's in fact a binary variable with just 2 categories, either the presence or absence of oral cancer. These categories are mutually exclusive and certainly do not have any meaningful numerical difference between them. So the answer for that one is nominal. Analgesic name is also a nominal variable because it categorizes different types of analgesics like aspirin, ibuprofen. There's no inherent order or ranking to these names. They're simply that. They're names or labels. So this is another nominal variable. The amount of fluoride in drinking water is a ratio variable because it is a continuous measurement, but also with a true 0 point. You could technically have 0 parts per million of fluoride, which means there's no fluoride in the water. And again, you can't go below that absolute 0. So this would be a ratio variable. Oral cavity temperature change measured in Celsius. So this is an interval variable because it has consistent and equal measurement intervals and lack of a true 0 point. In Celsius, 0 degrees does not mean the absence of temperature. It's simply the freezing point of water. And so the concept of 0 is arbitrary and does not represent a total lack of what's being measured, like in the Kelvin scale. If this was Kelvin, it would be ratio. Since it's Celsius, it is an interval variable. And lastly, alveolar bone loss in millimeters. This is going to be another ratio variable because it represents a continuous measurement of bone loss with a true 0 point, being 0 millimeters of bone loss or no bone loss at all. Now, hopefully these examples helped you solidify some of those concepts we talked about with regards to the scales or levels of measurement. That's it for this video lecture. Thank you so much for watching. I genuinely appreciate it. I'd also really appreciate if you consider clicking that like button below this video, subscribing to the channel if you have not already, sharing this video with your friends, and leaving a comment below letting me know what you thought. All of those things can really help to grow the channel. If you want to go above and beyond supporting me and what I do here, please check out the Patreon page linked below. If you want to join there, you'll get access to exclusive practice questions, exclusive study guides, a Discord server, and so much more. And if you see at the end of my videos, I have an end credits screen, and all of those names there are the names of my amazing Patreon supporters that I'm honored to have. Thank you again for watching, and I'll see you in the next video.